Okay, we'll look at the homework problems in section 10.4, which deals with the measures of central tendency and variation. In problem number one, you're going to calculate the mean, the median, and the mode for each of the following data sets. In problem number one, you got 1, 8, 7, 8, 3, 8, 10, and 3. Okay, before I begin this particular problem, what I'm going to do here is put these numbers in numerical order. That way, it'll be easier for me to find the median. So no, the 1 will be first. That's a couple of 3s, so I write the 3 twice. Let's see, 4, 5, 6. There is a 7, there are 3 8s, and a 10. So it should have 8 data values there. Okay. Now, I want to find out what the mean is. Anytime you're finding the mean, you want to take the average of that set of data. You just add those numbers together and divide by 8 because there are 8 data values here. So what I'm going to do is add 1, 8, 7, 8, 3, 8, 10, and 3. I'm just using the calculator to do this. So if I add those numbers up, I will get 48. 48 divided by 8, you're going to get 6. So the mean is going to be 6. Okay. The mean of that set of data is 6. I just simply added those numbers up. That gave me a sum of 48. And then 48 divided by 8, because at 8 data values, you'll get 6. Now the median is going to be the middle number. Now, I have an even number of data values, so what I'm going to do here is find out what my two middle numbers are. And I can do that by crossing out the numbers on the end, like this. So I get to the numbers that are in the middle. As you can see, it's 7 and 8. So to find the median, you have to take the average of these two middle numbers. So you add 7 plus 8, that will give you 15. 15 divided by 2 will be 7.5. So the median of that set of data is 7.5. And then finally, you want to select the correct choice. You want to find out, is there a mode, or is there, if there is no mode. In this case, there is a mode. That's the number that occurs the most frequent. In this case, it's 8. So the mode here is 8. Now here, there's only one mode. There might be more than one mode. You can't have that, or no mode at all. Okay, so that's part A of number 1. Part B, you're still going to find the mean, the median, and the mode of part B. That's 12, 15, 15, 16, 19, 18, 15, 16, and 15. All right, first things first, let's put these in numerical order. I think the lowest is going to be 12. There's 1, 2, 3, 4 data values of 15. There are 2 16s, an 18, and a 19. So there should be, in this case, 9 data values that I should have. Okay, now to find the mean, we just add those data values together and divide by 9, because there are 9 data values here. So I'm going to go ahead and type in the 12, 15, 15, 16, 19, 18, 15, 16, and 15. We'll take those numbers. That sum is going to be 141. There are 9 data values, so you'll take 141 and divide by 9. And they say for us to round to how many decimal places to the nearest thousandth, which is 3 decimal places. So it's going to be 15.66, and this 6 is going to be rounded up to a 7. So it'll be 15.67. $15.667 is your mean. The median is, of course, your middle number. And this has to be assorted data, which it is. Has to be placed in numerical order for you to find the median. And I'm crossing out the numbers on the ends till I get to the middle number. In this case, it's 15. So here, the median is 15. Okay, there is a mode. There might be more than one mode, but there is a mode here. 15 occurs 4 times. That's the most frequent data value in this set. So that means the mode is 15. Okay. And part C, we got 17, 24, 24, 15, 29, 17, and 14. So in this case here, let's first put these numbers in numerical order. Let's see, a 14, that's the smallest. Then 15, a couple of 17s, 2 24s, and 29. So there should be 7 data values here, which I have in numerical order. Now we can find the mean. Then 17, 24, 24, 15, 29, 17, 14. That sum is 140. Take 140, divide that by the total number of data values that you have, which is 7. This will give you 20. Okay, so the mean is 20 for this set of data. And we don't have to round to the nearest 1,000 because we got a whole number of 20, so we just type in the number 20. The median is the middle number, okay? So here you can cross out the first and the last until you get to the end, get to the middle number. In this case, it's 17. And is there a mode? Yes, there is. In fact, there's not only just one mode, there are 2 modes. 17 occurs twice, and 24 occurs twice. So we write down both 17 and 24 as the modes. So this is an example of a type of problem where with the mean, median, and the mode, with the mode you may have more than one mode. Okay, so that there is problem number 1, just finding the mean, the median, and the mode. Okay, problem number 2. The mean on a set of 26 tests was 78. What is the sum of all the test scores? Okay, to get the mean of 78, we have to take some number and divide it by 26. But we're going to do the opposite of dividing by 26. We're going to take the mean of 78 and multiply it by 26. So now you got 78 times 26, which is 2,028. So the sum of all the test scores is 2,028 because that sum had to be divided by 26 in order to get 78. So we're doing the opposite of dividing by 26. We'll multiply that 26 times the mean of 78. Okay. Number 3. The mean score on a set of 22 tests is 88. Suppose 2 more students take the test and score 70 and 61. What is the new mean? Okay, in this case here, we got 22 test scores with an average of 88. Well, that sum was 22 times 88. Multiply that out, you'll get 1,936. Now we're going to add the 2 scores from the 2 students, the 70 and the 61. So if you add 70 and 61 together, you're going to get 2,067. Okay, now we're not going to divide by 22. We have to divide by 24 because 2 more students took the test. So add the 2 more students to the 22 test, you now have 24. So we do 2,067 divided by 24. Now rounded to the nearest tenth, it will be 86.1. So now the new mean is now 86.1, which means the mean of those test scores has dropped since 2 more students took the test. Okay, problem number 4. In Lindsay's class, there were 5 students who scored 90 on a test and 6 students who scored 40 on a test. What is the mean of the scores in the class? Okay, now here we got 5 students scoring a 90, so that's 5 times 90, that's 450. Then 6 students who scored 40 on the test, 6 times 40, that's 240. Now let's add 450 and 240 together. That's going to give us 690. And there were a total of 5 and 6, that's 11. 11 students that took the test. So we do 690 divided by 11. And we're told to round to the nearest tenth, so it will be 62.7. So here, the mean score would be 62.7. Because you have 5 students took the test and another 6 students that took that same test. That's a total of 11. 5 scored 90, that's 450 total. 6 scored a 40, that's 240. Add those two, you're going to get 690. 690 divided by 11 would be, to the nearest tenth, 62.7. Okay, problem number 5 is a familiar situation dealing with grade point averages. Find the grade point average. Assume that the grade point values are 4.0 for an A, 3.0 for a B, and so on. And this is the courses that the student has taken and the credits and the grade. So this person got a grade of A, so that value is worth 4 points. The B's are worth 3 points, so here we'll put 3 here. The C is worth 2 points. Now the way we're going to do this, we're going to multiply the grade point value by the number of credits. So here 4 times 4, that's 16. And then 3 times 2, that's 6. Then 3 times 2, again, that's 6. And then 2 times 3, that's 6. Now we're going to add these totals together. 16 plus 6 plus 6 plus 6. That will give me 34. So those total points are 34. And I'm going to take that 34 and divide that by the total number of credit hours. Let's see, 4 plus 2, that's 6, plus 2 is 8, plus 3 is 11. So it'll be 34 divided by 11. And they say round to the nearest hundred, which means the 2 decimal places. That's going to give me 3.09. So this person's grade point average is 3.09. Okay, problem number 6. The youngest person in the company is 29 years old. The range of ages is 17 years. How old is the oldest person in the company? Okay, so we know the range is always the oldest minus the youngest. And that would give us the range. The oldest person we're looking for, we're going to let X be the oldest person, minus the youngest person in that company, that's 29. That's equal to the range, which is 17. So we got the equation X minus 29 is equal to 17. Now to find out what X is, we're subtracting 29, so we're going to need to add 29 to both sides. So here X is equal to 17 plus 29, which is 46. So the oldest person in that company is 46 years old. Okay. Problem number 7. To get a B in math, Alexandria Pappas must average 80 on 5 tests. Scores on the first 4 tests were 80, 78, 84, and 75. What is the lowest that she can get on the last test and still get a B? Okay, the way we're going to have to do that particular problem is this. The lowest B that she can get is an 80 on the average of 5 tests. So we do 80 times 5, which is 400. So that means the total of all 5 of her tests must be at least 400. She's already got 80, 78, 84, and 75. So we're just simply going to add those 4 test scores together. 80, 78, 84, 75. That would give us a total of 317. Now let's subtract the 317 from 400. So that means on the 5th test, 400 minus 317 will give us an 83. So Alexandria must make at least an 83 on the 5th test so that she can get a B in that particular math class. Okay. Okay, problem number 8. To the right are box plots comparing ticket prices of 2 performing arts theaters. And these are the box plots for theater A and B. And you're asked to answer these questions. Part A, what is the median ticket for each theater? Now, when you're reading a box plot, the median is always this line that's on the inside of this box right here. That's your median, which represents the 50th percentile in a box plot. So for theater A, the median price ticket is 71. And for theater B, the median price ticket, if you look at the theater B, that's this line right here, it's at 59. So the median price ticket is 59. Okay, now in part B, which theater has the greatest range of prices? Okay, look at this box plot for theater A. The lowest is 53, the highest is 89. So if you do 89 minus 53, that would give you 36. That's a range of 36. But for theater E, the lowest price ticket is 47, and the highest is 71. So if you do 71 minus 47, that would give you 24. You can see here that theater A has the greatest range of prices, okay? Because that range is 36, which is bigger than the range for theater B, which is only 24. Okay. Now part C, the highest price ticket is how much at which theater? Well, the highest price ticket by looking at this is just 89. That's the highest. And it's in theater A. So here, $89 at theater A. And then part D, choose the correct answer below. Either theater A has the highest price tickets because there is more variation in prices at theater B. Theater B has the higher price tickets because there is more variation in prices at theater A. There's more variation in theater A. Also, there are higher price tickets in theater A. Or there is more variation in theater B. Also, there are higher ticket prices at theater B. In this particular case here, I would choose this one. Because of the variation, there's more variation in theater A than it is in theater B. Also, theater A has the higher price tickets. Okay? Because theater E's highest price ticket is the median of the theater A. Okay. Okay, let's look at problem number 9. You have 7 students on a intramural team that weighs 157 pounds, 169 pounds, 152 pounds, 163 pounds, 159 pounds, 178 pounds, and 156 pounds. What is the standard deviation of the weights of these students? Okay, now in a lecture video, I showed you the formula that they use in the textbook. However, there is another way that we can find the standard deviation. And I'm going to give you this formula here. Lowercase s, which is your standard deviation, is going to be this. It's going to be the square root of n times. Now, this symbol represents the sum of all the x, and that's squared, the summation of the square of your x's, minus the square of the summation of x. And that's divided by n times n minus 1. And what n is the number of data values that you have. Okay? This is a much easier formula than the one that's in the textbook. And in the video, they do give a long list of how to come up with that standard deviation. This one is much easier to do because the only thing you want to know are x and x squared, and the summation of x and the summation of the squares of x's. Okay, so in this case here, I'm going to draw a table with just x and x squared. Now I'm going to list those data values in numerical order. Got 157, 169, 152, 163, 159, 178, 156. And I'm going to go ahead and take the sum of those x values. Okay, so if you take the sum of those x's, let's see, 157, 169, 152, 163, 159, 178, 156. That sum is 1134. Now for the x squares, I'm going to square each one of those individual x values here. So if I square 157, that's going to give me 24,649. Square 169, that would give me 28,561. Square 152, that would give you 23,104. Square to 163, that's going to give me 26,569. Square to 159, that would give you 25,281. Square 178, that would give you 31,684. And square to 156, that would give you 24,336. Now, if I take the sum of those x squares, I'm going to get 184,184. Okay. So now, this is the formula that I'm going to use with these values here. Okay. So now, this is what S is equal to. And this is the square root of N. There are, in this case, 7 students. So that means N is equal to 7. So that's 7 times the summation of X squared. That's this number right here, 184,184, minus the summation of X, that's 1134, and that's going to be squared, divided by N, which is 7, times, again, N is 7, minus 1. Okay, now I'm going to use my calculator to calculate the numerator and the denominator individually. And then whatever that is, I'm going to take the square root. Okay, here's how I'm going to enter this. The numerator is 7 times 184,184 minus 1134, and that's squared, so you hit the X square button for the square. Hit enter. That numerator is 3,332. Now, the denominator is going to be easy. I can do 7 minus 1, which is 6. And then 6 times the 7, that's 42. So now I got 3,332 divided by 42. That's going to be 79.333 repeating. So now I have S, which is equal to the square root of 79.333. And if I take the square root of that, when you do the square root, second X squared, I'm going to take that answer. That would be about 8.9. So the standard deviation there is 8.9. Okay. That's how you compute the standard deviation using this formula, which I call the shortcut formula. It's much easier to do it that way than it is using that long procedure that's in your textbook, where you have to find the mean, and then you have to subtract the mean from each of those data values, and then square them, add them up, divide by, I think, 7. Okay, take a look at problem number 10. The scores on the test are listed on the right. Find the mean, median, mode, IQR, which is your interquartile range, the variance, and the standard deviation of those scores. Okay. I'm going to tell you what. Instead of doing it the long way, let's use our calculator to do this, because we can use the calculator to find the mean, median, and mode. Well, not the mode, but there are other things I can show you how to use the calculator to do. Okay. These are our data scores on right here. Now, on the calculator, you're going to press the stat key, and then under edit, you want to select number 1 for edit. Okay, and we're going to type in these data values in this column, which says L1, and we're going to enter each data value one by one. So this is 70, 71, 70, 81, 77, 64, 76, 72, 77, and 75. And make sure you hit enter after each individual data value, including the last one. Okay, now let's hit second and mode to get out of this. Okay, now we want to press next the stat key. You want to use your right arrow key to highlight this menu that says Calc. And the one you want to select is number 1, which is one variable statistics, or one variable stats. Okay, and the list is stored in L1, so that's what the one that you want. And then you hit your down arrow key to highlight calculate, and then hit enter. And notice part of your answers are already here. Here you see the mean, which is your X bar, that's 73.3, which is what we're looking for. So the mean is 73.3. Okay, now we don't know what the mode is. We'll just have to look at this set of data values to find out which one occurs the most frequent. In this case here, the mode, I'm thinking, is going to be 70 and 77. Because I only see 70 twice, and I also see, actually it's 70, it's just 70. Because 70 occurs 3 times, and 77 only occurs twice. So 70 is just the mean, the median. Correction, it's the mode. We haven't gotten to the median yet. So the mode is 70, not the median. Okay, now for the rest of these, look at the variance. Okay, before I get to the variance, let's get to the standard deviation. The one that we want is this one right here. And it's to the nearest tenth, where it says sigma of x. That's the standard deviation we want, which is 4.6. So the standard deviation there is 4.6. Okay, now I'm going to show you how to get the median. If you use your down arrow key, this part represents the 5-number summary, where the minimum is 64, the maximum is 81. These are your Q1 and your Q3. The one that says MED, that's your median. That's this answer right here, 73.5. So the median is 73.5. And then your IQR, if you recall, the IQR is always Q3 minus Q1. And in this case here, Q3 was 77, Q1 is 70. So here, 77 minus 70 is 7. So the interquartile range is 7. Okay. Now, I'm going to show you how to find the variance. The variance is always the square of the standard deviation. So in this case here, let me go back to one variable stats. You'll see that your standard deviation was 4.605. You can take as much as that decimal as you want to, and then square it. Okay, and it will be 21.206 as your variance. Okay, they want you to round to the nearest 1,000 or to 3 decimal places. Okay, so that's how you can use the calculator to find the mean, median, and the interquartile range. And also you can use that to get your 5-number summary, which will help you draw a box and whisker plot. Okay, and finally number 11. Fuel economy estimates for automobiles built in a certain year predicted a mean of 24.8 milligrams and a standard deviation of 7.2 miles per gallon. That should be 24.8 miles per gallon for highway driving. Assume that a normal distribution can be applied. Within what range are 68% of the automobiles? Within what range are 68% of the automobiles? Okay, now the normal curve if you recall, on one of the lecture videos for section 10.4, looks like this. Okay, the mean is right here, and that's what, 24.8. Now, based on the empirical rule or the normal curve, 68% of the data values are within one standard deviation of the mean. That means this is x bar minus one standard deviation, and this one is x bar plus one standard deviation. 68% of the data values are within one standard deviation of the mean. 95% of the data values are within two standard deviations of the mean, and then 99.8% of the data values are within three standard deviations of the mean. Okay, so 68% represents within one standard deviation of the mean. Okay, so if the standard deviation is 7.2, add 7.2 to 24.8, and you're going to get 32. And then subtract one standard deviation from the 24.8, you're going to get 17.6. So that means the range for those 68% of those automobiles are within 17.6 miles per gallon and 32 miles per gallon. Okay, that's how we use the empirical rule to help us solve these particular types of problems. And hopefully this will assist you with some of those homework problems in section 10.4.